Okay, today is about expected value. We've got done with the Venn diagram stuff, and now we're on to expected values. They use probabilities, but their answers are not probabilities. The answer to an expected value is what you should expect to happen in the long run. When you go to a casino, do you either, in any particular bet, you either win or you lose? Do you get that? And on average, in the long run, are you expecting, if you're smart anyway, are you expecting to win or lose? Lose in the long run. Your average expected value then is negative. Do you get on any individual transaction though? It's not an average. It's just like you either won or you lost. Okay, but you can break it down and say on average, the average person that goes into a casino loses about 50 bucks. And again, that totally depends on which kind of casino, where is the casino, how much for the, is this in Macau where the big spenders in China are, or is this on, is this in Las Vegas, or is this in a Minnesota casino? And it could change, but we're going to use 50 bucks on average as that's an expected value. It comes from probability and it comes from amounts. And so I'm going to keep coming back to this. Probability times the amount, then add. I just want to throw it in there right now so your subconscious can start remembering that. Probability times the amount, and then you're going to add. I want you to take a guess. Where I'm going to touch this thing and it's going to spin. I want you to guess what color it's going to land on. Okay, just take a guess. Everybody got your color? All right, here we go. And it's orange. Okay, so take another guess. Orange again. Take another guess. Take a guess. Quick, quick, quick. Oh, it's blue this time. It is. I can see purple underneath that line. It's definitely orange. Or blue, or whatever you want to call that color. It's kind of a purpley blue. What's that one? All right. Now, the point is, you could play this game where, how about this? If I let you play this game for free, would you play? No brainer. Okay. How about if the game cost $1? $1 to play, and if it lands on this, you get nothing back. If it lands in orange, if it lands on red, you get $5 back. If it lands on green, you get $10 back. Okay. Would you play if it was cost $1? All right. Unless you think I'm going to cheat somehow, which obviously is an important factor. And also, there is some just like moral implications. Some people are going to say, I don't gamble, and therefore I would not play. Even if it's a great deal, I wouldn't play. But assume for a moment that you don't have a problem with that, the gambling being a problem. If that's not a problem, $1 is a pretty good deal for this. You'll lose 25% of the time, but then all the rest of the time, which is 75% of the time, you'd make money. You get how that's $1's a good deal, right? Okay. How about this? Would you pay $18 to play? Clearly not. That'd be just stupid. Every now and then you might win a couple bucks, but most of the time you'd lose money. What expected value is what would be the exactly fair price to play this game? Because all of you would play for $1, and if it cost $18, nobody would play. But where's that exactly fair amount? I want you to take a guess. Don't say it. I want you to write your guess on your iPad. What do you think would be a fair amount? Now, don't look at other people's and get an idea from them. I mean, they might be totally off. That might be just mess up your guess. Take your best guess on what the fair price is. And I'll tell you before I calculated what I thought the fair price was. And then we'll see how many of you are over or under me. And then I'll tell you what's the actual, real, fair price. All right, well, we're getting those last couple guesses. Would you grab your graphing calculator? It doesn't have to be graphing, actually, but I think they pretty much all are in here. So grab your graphing calculator if you have one. If you need to borrow one, make it fast. Leave me some collateral. All right, remember me saying, or that's fine too. Remember me saying that it's P times A, then add them up? What's the probability? Oh, wait, first show your guess to the person next to you. Rows 1 and 2 compare. Rows 3 and 4, rows 5 and 6. They'll probably be different. This is just a best guess. I'll tell you what my best guess was last hour before I actually calculated it. My best guess was $8. My best guess was $8. Okay. How many of you are above $8? How many of you are below $8? All right. So most of you thinking it's less than 8. All right. So again, I know you don't know, but let's figure it out exactly here. P times A, then add them all up. Here's the probability of this. Would you agree? There's a 1 in 8 chance of that coming up. True or false? False. Good. So there's actually a probability of what? 1 in 4 chance. And I take that times that. This is the P. This is the A, the amount you get. And what do you get for that? 5. Some of you can do that in your heads. That's good. Okay. How about the green section? What's the probability of that one? 1/4 times the amount gives you 250. What's the probability of the red one? 1/4 times the amount. This one you might be able to do as a fraction. 5/4 turns into how many dollars? $1.25. Good. And you could use the calculator for that. And this last one is 1/4, but it doesn't really matter because you're going to times it by the amount, and you're going to get what? All right. So that plus that plus that, $8.75. Guessed it on the nose. You guessed it on the nose too? All right, nice work. Well, who was within $1 of that guess? How many of you are within $1 of $8.75? All right, cool. So you guys have good instincts for this then. Okay, so do you think the casino actually charges the fair price? No. So then how much do you think they would charge? If it's $8.75. All right, now think marketing wise. If you're a casino and you want people to try to play this game, you want to try to get people to play. Maybe they make if they make it like 2 spins for a certain amount of money, it makes it harder for people to like do the math on what's it really worth. People do that in the grocery store all the time. Buy 7 avocados for $13, and they're like, oh, I don't know. I guess I'll just buy 7. And so here's what I think. My theory is they charge $9. We don't know, but this casino does not need to make a ton of money because on average, as long as they're winning, they don't need a huge margin. They might make 2, 3, 4% on average in a casino. That means on a $100 payout, they'd pay out 94 cents. Get what I'm saying? They pay $94 out of $100 or 94 cents out of every dollar. They pay back. They pay out. Why? Why do they actually want to pay out almost fair? Yes? Yeah, because if everybody loses every time they go, how long do you think it'll take before they quit? You know what I mean? If a person goes and loses, goes and loses, goes and loses, goes and loses, and it's like, you want to go to the casino? They'll be like, I just lose every time. It's not worth it. But if they like lose, win, and they're like, ooh, I got a chance. I actually am excited about going, and then they'll go again. Maybe they get lucky and win again. Now they're like totally hooked, and now they go like 4 times again, and they have to win every now and then. So the point is, they're not going to set a huge margin. So a 25 cents margin is probably, in my opinion, enough to make it look cheap. $9 looks cheap compared to $10 anyways to play. And a lot of people will see, oh, I could win if I get this or this. You don't want to have them saying, well, I'm just going to break even here. The only time I'm really going to win is here. I only have a 1/4 of the time I'm going to win. So you see what I mean? They might buy it more if you put it at $9 instead of 10. But they still have an advantage. They don't need a huge advantage. All right, so this was the expected value. And this is my theory on what they would charge. But you can have your own theory because this is all made up anyways. All right, yes?
For McDonald's, like another Monopoly thing.
Yep.
Like when it says 1 in 4 ways to win, what's that really saying, 1 in 4 ways?
When it says 1 in 4 ways you could win, I think what they're trying to say is not like each little chip has a 1 in 4 chance. It's that you might, on the little chip that you get, you might complete a Monopoly with it. There's a chance of that, but those are more rare. But a lot of times on the little chip, the Monopoly chip, it'll say you won a free hamburger You know what I mean? Like give you something cheap that's free. So they're trying to say that there's a fairly good chance you're going to win something. It's just that the actual winning, like the $500 or the $1,000 or the free house or whatever, there's a really low chance of that. But they'll give away a lot of little stuff like hamburgers. So they put all that in there together, and then they can say something like 1 in 4. And I don't know what their exact wording is, but that's what they're trying to do is make it sound like, geez, or I have a 1 in 4 chance of winning. Yeah, you don't have a 1 in 4 chance of winning the house or the car, but you have a 1 in 4 chance of winning something. Yes.
With pricing like the 875 price,
Yeah.
could you also work to like find the average or
That's a very good question. If you just average these 4 numbers in this case, it would have been the expected value. But here's where that would break down. If you had a circle that was like this, where this, if you hit in the black part of the circle, you win, and if you get in the white part of the circle, you lose. You don't want to just average those. The reason is because the probabilities are so different. On that other one, all the probabilities were the same, so you actually could just average them. For most of our problems, there'll be different probabilities. So like this one obviously has a much higher chance. It's even more than 3/4. It's probably like 4 out of 6 chance of winning this area, which is like, I don't know, 4/6 is like 2/3, like 67% chance of winning if hitting the black. And let's say that comes up with win $3, and over here it's lose $1. Okay, then you could do your P times A and add them up, and you would not just average your 3 and your 1. All right, let's move on. What is expected value? It is the sum of the probability of each possible outcome multiplied by the outcome's value. I like to say P times A, then add them all up. And it will be the average amount one expects as the outcome when you do it many times. So probabilities times the amounts, and then you add them all up. See how that works on a different kind of problem. Here's a probability and an amount, but this isn't money this time. It's good for you to get that these aren't always about money. Casinos are great examples because you can all relate to them and we all understand value when it comes to money. But this is a probability and an amount, and I still could do what I just told you seconds ago. What do you do?
On the
Probability, and then times it by? Find the probability, times it by the, apparently you guys didn't write this down. P times A, then add. Okay, so what's P times A in this case? Well, probability times amount of what, dogs? Amount of credits. So figure out what P times A is here, get an answer. Figure out what P times A is here, get an answer. Here, get an answer. Here, get an answer, and then add those all up. Do it. See what you come up with. And when you're done, just make sure you get what it means. Let's say it's 17.9. Is it like the number of chickens that we need to harvest to feed the class? Of course not. Figure out what it is and label it. Okay. All right. Somebody give me P times A for that first one. What'd you get? You already add them all up, I suppose? 0.7. Who's got the next one? Say it if you know it. Next one. And when you actually add them all up? Awesome. And that's the number of chickens in Uganda. No, it's actually the number of credits that what? The first year freshman. And what the heck is a first year freshman? Well, you could be a freshman in your second year because you didn't do so well your first year. Okay, so your first year freshman, first year student, okay? And the reason this actually matters is you get to pick when you go to college. Did you know that? Some people take like 20 or 24 credits. Okay, and they're saying in this case the average at this school is 15.3 credits. Okay, and the reason that we can do it that way is because we have a probability of each of these things happening, and then we multiply by the amount of credits. Why do people take so many more credits than other people? Yes, get done earlier. Very good. And it's cheaper. Here's why. because once you hit a certain number of credits, a lot of schools say every extra credit you take is free. So in other words, if you were going to take, let's say 14 credits anyways, they'll say if you take more than 14 credits, all the extra credits are going to be free. So if you could handle it and you could take like 23 credits every quarter, you might be able to graduate in like 2.5 years for the same exact, I mean, like way cheaper. Like it was the same price as it would have been if you had gone those 2.5 years only taking normal amounts of credits. So the moral of the story is if you could handle it, if you could take lots of credits, it is harder because you're taking all these classes at once, but you could get it way cheaper. So for some of you that are looking for a way to save money in college, it's a little bit depressing because you have to work harder, but you could probably get done in 3.5 years. And if you're actually paying the bill, you know, that's a different story than if like somebody else is paying for it. If you personally had to shell out an extra $8,000 for that last semester, you might say, man, I'm going to save $8,000. Okay, I'll take more classes. So, true. Not just the class price, but she made the point that you save on living expenses that last semester. You don't have to pay for your room anymore. You don't have to pay for your food at college anymore. It might be cheaper at home. All right, so I'm not saying everybody should do that. I'm just saying, why does this even matter? Because if you load yourself up with lots of credits, a lot of times it doesn't cost any more than if you just had a normal amount of credits. All right, let's move on to this one. This one is not about credits. It's not about money. What's it about? Exam what's? Multiple choice questions, which, what do you get on these? You get points. So in the end, it's a probability times the amount, and then you add them all up. But there's 100 questions. Do you actually think I want you to add 100 things? No. Let's do the P times A part and just figure it out from there. What's the probability you get a question right? Well, there's 1 in 5 of the choices is correct. So if you're just guessing, what's your probability? 1 in 5. 1 in 5. Okay, that's the probability. What's the amount of points you get if you get that? 1. Then you'd have to do that and then add it up 100 times. What's smarter than adding this to itself 100 times? Times it by 100. Do you get how that's the then add part? Is instead of actually adding the same exact thing 100 times, you times it by 100. And what does that come out to? 20 points. That's the number of points that you'd get if you just totally guessed on a test. Sometimes teachers call that the monkey score. As in, if I gave this test to an orangutan and I gave it to you, if you can't beat the monkey, as in the monkey would have guessed and got 20, and you hopefully will do better than that. That's the monkey score. Okay? That means it's tough if you can't beat random chance. That means you probably didn't know what you were doing at all. Although I have had kids that have done worse than the monkey score. And I have one test I have still saved in my desk from many years ago. And it's the monkey score opposite. It's like the ultimate worse than a monkey. 25 questions, every single one wrong. Think about that. Multiple choice. 25 multiple choice questions I triple checked it because I thought there's no way. What are the odds of that? And actually I figured it out, and it was like 1 in 1,000. 1 in 1,000 chance that you would guess that badly to get. And I thought the same thing. Maybe the kid was actually a genius, figured out all the right answers, and just decided to like pimp me by like purposely choosing the wrong answer because it's so hard to do. It'd actually be much more likely, you're right, that's good thinking, that the kid was a genius and decided to purposely make everyone wrong. But if he's actually that smart, I probably would have noticed on the rest of his tests and stuff, you know? Because some of you, I don't think anybody in here would be able to do that. I mean, it's just, no, I don't mean, no. What I'm saying is, I don't think any of you can get a none right on your test unless you were doing it on purpose, meaning Because there's a lot, because there's a lot of you who could get a perfect paper. I've seen lots of perfect papers, and all it is like you find the perfect paper and then you change every answer, right? But that's much more likely than actually being that terrible at it that you can't get even one right. Anyway, all right. So, let's move on. Oh wait, final answer on this was 20, and yep, they got 20 also. Okay, good. So, this one. When you get stuck on the probability part, I encourage you to draw a tree. In this case, there's 52 cards, 4 of which are aces, so don't make a draw for every single card. It's just either you get an ace or you don't. Ace, apparently was spelled with 2 E's, or not. I'd like you to try to figure this one out. It's P times A, then you add them all up. See if you can figure out what you would get. You get an amount of money in this game if you get an ace. If the whole gambling aspect bothers you, think of it like at prom or other like class parties at the end of the year kind of thing. Sometimes they'll have like a fake casino that comes in, and you can like gamble with this fake money they give you, and whoever has the most wins a prize or something. So anyway, if the gambling part of this bothers you, imagine that it's just a casino night at the prom or whatever. Fake gambling. I'll pause for a second while you try this one. So let's see. Your probability of an ace, I hope you thought was 4 aces out of 52, which you could reduce, but it's still going to be a number that isn't so easy to work with. Let's get a decimal for it. What is 4 out of 52 as a decimal? Point what? That'd be 92% chance. I don't think so. Oh, the other one. Okay, 0, 7, what? Okay, and then how about this one down here? 9, 2, what? Okay, thank you. So there's probability of getting the ace, probability of not getting the ace. If we get the ace, we get 15. If we don't get the ace, do you think I'm going to put a buck there? What am I going to put there? Negative a buck. All right. Now I multiply this out, and the P times the A, and I get a positive amount, and it is how much? Okay, and then how much is this? Well, I can do it because it's just timesing by 1, but it turns negative, so negative 92 cents. And then if I actually subtract these two, because one's positive and one's negative, I'm adding them, but one's negative. So when you add it all up, you still have a positive expected value. I think it's about 23 cents. Does that mean that every time you play the game, you will win 23 cents? No. What does it mean? In the long run, on average, you'll win 23 cents each time you play. Not when you've played it 400 times, you've won 23 cents. It's 23 cents on average for each time you played. Do you get how you are winning and therefore you have a positive expected value? All right. So what if we change the game just a little bit? I did the other one. You try this one. I strongly recommend a little chart for getting heart or not, and see if you get the right answer for this. Compare with the kid sitting next to you. I'll pause for a second while you try that. All right, let's see if you did this one right. Probability of a heart was 13 out of 52. That one I can reduce simply. What is it? 1 in 4. Good. And that means 3 in 4 chance of not getting a heart. And then if I get a heart, I get $5. And if I don't get the heart, I lose a buck. That's negative 1. If you go this times this, I can do that in my head. That's 5/4. It's 1.25. And if I do this times this, that's 3/4 times that. Think of it in money, it's 75 cents lost. Net 50 cents. And is it positive or negative? Positive 50 cents. That means your expected value is 50 cents. Compare that to the other game. The other game was how much expected? 23. This one's 50. So this is a better deal even. If you had a choice between 2 casino games side by side, and you quit and did the math on it quick because you're gonna like spend all night playing the casino games, you'd pick that one because you got a better chance of winning. Your expected value is more. Okay, so P times A, then add them up, has one more type of problem that I need to get you through, and that is Have you guys ever heard of the insurance you can buy when you like buy an iPhone, like Apple Care? Okay. And generally, I'm sure most of you have heard that it's a ripoff. It's like they charge you more than what it should cost for it. But it all depends on you, in my opinion. I don't think all of these insurance programs are automatically ripoffs. A lot of them are, but if you think that your probability of breaking the phone or whatever is higher than average, then you could actually get these to be a good value for you. Okay, do you guys get that? Like some people, like you would say, it's like a 98% chance that she's gonna break that phone because she like breaks everything she touches. I got an uncle who's like that. I love him, but man, like breaks things constantly. Okay, so he should buy the insurance. And the average person, maybe it's not gonna make could be a good deal for them, but people's probabilities are sometimes different based on them. Also based on usage. I've done it before where I had one thing, I knew we were going to use it kind of hard, and so I bought the protection plan on it at Best Buy, and I was able to turn it in 3 times because the things kept on breaking and they kept on giving me new ones. So it's not always a bad deal. I was really happy I bought it for those 3 times. So I don't want to make these sound like they're always a bad deal, but on average, yeah, on average, they usually aren't a great deal. Okay, so the expected value, it's always P times A and then add. So the two things that can happen here are you buy this protection plan and the thing either works or it breaks. And you have to be able to, they have to tell you what the probability is. The probability the camera will break is 2%. So 0.02, then what's the probability it works? 0.98. How much do you get when you go back to the store and say, hey, my camera is working? How much are they going to give you? Nothing. They're going to give you nothing if it works. Does that make sense to you? If it works, you go back and you ask for money, they're going to give you nothing. If it breaks, though, and you had the protection plan, you will get $300 back in this scenario. So breaks, the amount you get, $300. P times A, then add. The cool part about doing it this way is here's probability times by 0. It's always 0 for the works part. Then we just have to do the breaks, which is 0.02 times 300, which comes out to $6. Now that's the, P times A, and then what am I supposed to do? Add. What's 0 plus 6? 6. That's the fair price of the warranty. What do they actually charge? They actually charge $75. So if this is the fair price of the warranty and I pay $75, you have to subtract that because it wasn't factored in here. This wasn't factored in. The 75 wasn't there. The 75 wasn't there. So you do P times A, then add them up. Then you have to subtract off the cost. This is a net of negative 69, I think. Is that right? Yep. That means on average person then loses $69 on their warranties. And this is not a fact. It depends on the problem. But I would say on some devices there's a way higher chance than 2%. Like for you with iPhones, how many of you have had a smartphone break on you? Okay, and that's like at least 3/4 of the room. And some of you multiple times. Okay, and it all depends on how you use it. If you're a guy carrying it in your pocket, you probably maybe are safer than a person who has it in all kinds of places. If you're a person who carries it in or has it in a case, much less chance of breaking it. If you're the type of, and again, it depends on you and how you use it. If you're the type of person who's generally kind of clumsy, you drop things, well, you're going to break it more. If you're the type of person who's a ninja, you probably could drop it and then stop it with your foot. I've done that. You did that today?
Yeah,
drop your phone.
Caught it, and it just,
Yep. If it hits your foot, then a lot of times you can keep it from breaking. So, all right. Anyway. I'm sure. Ooh, like silent ninja.
Someone saw me. I was like, no.
Yes, and it never happened. Can't prove it.
Exactly.
All right.
Probability was
So, when you do these, here's the most common mistake. People forget to factor in the cost of the warranty. They'll say, oh, look, it was +6. It was a good deal. You never factored in the fact you had to pay money for it. So don't forget to subtract your 75. This is the final expected value. This other thing, that was the fair price. that's like what the expected value would have been if they hadn't charged you anything. So what they should have charged you to make it totally fair would have been $6. But these evil companies want to make a profit. I don't understand that. Obviously, they want to make a profit. That's the point. So, all right. That last kind is going to be your toughest one. The homework worksheet, if you look at it now, we're almost done here, so I'm okay with you not taking it out, but try to remember this. The very first problem you can skip, and I'll let you skip the very last one. So today it's skip first and last. Okay? Skip the first and skip the last. All right, and that's all I got for you for today.